2.4 mini lesson. As a class assignment, your group records the distance in centimeters that a snail travels for a certain time in minutes. The results are recorded in the table. So here's my table. First thing it asks is define variables for the quantities that are changing. So I am going to use m for minutes, and I'm going to use d for the distance. I could have selected t for time. It doesn't matter. The table of values represents a proportional relationship. So because they're telling me this, I know that all these relationships will be the same. So how can I determine the constant of proportionality? I can find the constant of proportionality when I know that there's a proportional relationship. So the easiest to do is take the smallest number from the table. And remember, we saw that constant equals y over x. So this is my x, here's my y, and I'm going to use these numbers. So my constant k equals 11 over 2. Now I could check that with every single one of these. This would be another easy one to check. 66 over 12. I see 6 goes in here, 6 goes in here. It would actually work the same for these. I know they're decimals, so it makes it a little more complicated. 27.5 over 5. I don't like having decimals within fractions, so I'm going to move the decimal over and turn this into 275. So then I have to do the same down here, so it's like I'm multiplying this by 10 and this by 10. Now I see they end in 5 and 0, so 5 goes in here 10, 5 goes in here 55 times, and then I still see 5 goes in here 11, 5 goes in here twice. So all the time, when I know it's a proportional relationship, I will get a constant, and that constant in this case is 11 over 2. So what is the constant? 11 over 2. How I can determine it, I can put the y over the x. Now they want me to set up a proportion when the snail travels 2 minutes. So if I go back to the table, 2 minutes is 11 centimeters. So I have 11 centimeters, 2 minutes. And so this would be m, and this is my distance. I'm going to call it d. So I'm using those variables that we defined up here. 11 centimeters is the distance, 2 minutes, m for minutes. Question 5 says to use your proportion. So I'm going to rewrite it. 11 centimeters, 2 minutes, and that was the d over m. Now they want me to write an equation for the distance the snail travels, okay, based on the time. So this is what they told me first. That's the variable that I'm going to want to isolate. So I'm going to use means and extremes. So I'm going to say 2d equals 11m. I want to isolate for the distance. So if I want d alone, I need to divide both sides by 2. And I see that I get d equals 11 halves m. Hopefully you're seeing that this is my constant. So now they asked how far will the snail travel in 38 minutes. I'm going to go back. It was 11 centimeters in 2 minutes. So 38 minutes will go down here, and this will be my centimeters. So I'm going to use means. Well, actually, I'm going to scale up. I'm not even going to use means and extremes. I see that 2 times 19 is 38. So if I take 11 times 19, I'll get my solution, which is 209 centimeters. Okay, here's one more. How long will it take the snail to travel 144 centimeters? Assume that the snail will travel at a constant rate. So I'm going to go back to my proportion again. 11 centimeters is 2 minutes. Centimeters, minutes. So 144.5. And this is my x. Here I don't know how to scale this up very well, so now I am going to use means and extremes. 2 times 144.5 equals 11 times x. 144.5 times 2 is 289. That equals 11x. If I divide both sides by 11 and I round, I'm going to get 26.27. And I have to use my label. So it's a little over 26 minutes. This is the end of the mini lesson.